Hi there, this is Math 7, Unit 6, Lesson 14, Finding Solutions to Inequalities in Context. And today we're talking about a few things. We're talking a little bit about what are called negative coefficients. Okay, so we're looking at some negative numbers today. And the question you probably want to ask yourself a lot today when you look at things, when you find a solution, is does this make sense? So if you were to come up with an answer and you think, I'm not sure if that makes any sense, maybe something's not quite right that we need to take a look at it and look a little more closely at. And that's going to happen a lot when you're dealing with inequalities. You're talking about something that's greater than or less than, and you start dealing with negative types of numbers, it's going to change how you look at things. So today's lesson is a little bit of that. We're going to use some reasoning rather than rules. We're going to look at some reasoning for what makes the most sense. Okay? So first of all, we have this section called Solutions to Equations and Solutions to Inequalities. So solve negative x equals 10. So if I'm thinking about actually solving this one here, and I'm thinking about how do I solve this, I need to find a value of x that's going to be equal to 10. Well, I have a negative here, a negative there, and I need to put something in the place of x to make it equal to 10. Just using some logic here. If I have a negative in front and I put a number here to make it equal to 10, I need to put in there a negative 10, because a negative and a negative will become a positive, and then I actually end up with 10 equals 10. Okay? So when I look at something like this with an inequality, okay, and we're looking at a negative x or a negative number inside that space, a negative with times a negative number to be greater than 10 here, the same idea is somewhat true. Okay, if I place within here a, now first let's put the negative 10. If I put the negative 10 in here like before, I end up with 10 being greater than 10, which is not actually true, is it? So that doesn't actually work. So let's try a different number. Let's try a number like, because it's going to be a negative, let's try an 11. So a negative 11 becomes a positive 11. And is that greater than 10? Yes, that would be greater than 10. So I know that negative 11 would work. And in the same way, probably something like a negative 12, because that becomes 12 is greater than 10, would also work. So as long as I'm having a number that is any number essentially, so a number less than negative 10 is going to work for that situation there. Any number less than negative 10 would work. Negative 11 is less, negative 12 is less. And so we can just see this is kind of how this works. It's a little different, right? You use some logic and reason to see, well, what do you mean exactly? Let's take a look at this one. If I was to do my normal solution, I would divide both sides by 2, and that would tell me that x equals negative 20 divided by 2 equals negative 10. Now when I get over here, let's say I was to put negative 10 in there. I would have 2 times a negative 10 is greater than negative 20. But we know that that's not true, because that becomes 2 times negative 10 is negative 20. So I can't do negative 20 is greater than negative 20. That's a false statement. It doesn't work, right? So I can't use that. So what kind of number could I put there? Well, I want something that's going to be true. And I notice when I put a negative 10 there, I end up with a negative 20. I need to get something that's going to get me larger than negative 20. So let's try a negative 9. Okay, 2 times negative 9 is a negative 18. Is that greater than negative 20? Yes, it is. So that's going to work there. If I did a number like, let's go with 0. 2 times 0. Is that greater than negative 20? Yes, it is. 2 times 0 is 0. That's greater than negative 20. So in this case, any number, what we're seeing here, negative 9 and up, greater than negative 9 is going to work for this inequality. So there's a range of numbers that could work for both of these inequalities here. And so you just need a little bit of logic to think about what type of number that could be and where it would be like on a number line. Okay, let's take a look at some situations here. It says Andre has a summer job selling magazine subscriptions. He earns $25 per week plus $3 for every subscription he sells. Andre hopes to make at least enough money this week to buy a new pair of soccer cleats. Let N represent the number of magazine subscription Andre sells this week. Write an expression for the amount of money he makes this week. So an expression means not an equal sign for what he makes this week. We know he's going to make $25 a week plus for every magazine subscription, $3 for every subscription. That's our expression for what he's going to make this week. Okay, $3 for every subscription plus the $25 per week that he's going to make. Now, the least expensive pair of cleats Andre wants costs $68. Those are the least expensive, the cheapest cleats he can get. Write and solve an equation, it means we're going to have an equal sign here, to find out how many magazine subscriptions Andre needs to sell to buy the cleats. So, if he makes $25 plus $3 for every subscription, and he has to have a total of $68, how many subscriptions does he need to sell in order to make sure he has $68? Well, we'll solve this like a regular equation. We'll subtract 25 from both sides. So that 3n equals, in this case here, 43. We'll divide both sides by 3. So that n equals 43 divided by 3, which ends up being 14 1/3. So he needs to sell 14 1/3 subscriptions in order to at least get $68. Right, and you probably can't sell a third of a subscription, so we would probably say he needs to sell at least 15 or more is the idea. So just 15 plus. If Andre sold 16 magazine subscriptions this week, would he reach his goal? And we would say yes, he'd reach his goal. And the reason we say yes is that because 16 is greater than 14 1/3. So that would work for our equation that we had there. What are some other numbers of magazine subscriptions Andre could have sold and still reached his goal? Again, anything greater than 14 1/3 is going to work. He could have sold 15 and it'll reach his goal. He could sell 20, he could sell 100, and he would reach his goal. Now to write that as an inequality, it's the same idea, except now it's $25 a week plus $3 for every subscription needs to be greater than or equal to 68. He wants to make at least 68, but he could make more. So we're going to say it can be greater than $68. So that's why we say greater than or equal to. That's our inequality. Now the next one says write an inequality to describe the number he must sell. So that essentially means solve that. So we're going to solve that up there, but it's a solutions with an equal sign. When it says write an inequality, we're still going to express it with a greater than or less than sign. Okay, so we'll still use one of these kind of things. So to work this out, you end up doing the same idea that we did before, right? And so you end up with your n value is greater than or equal to 14 1/3. I don't need to do the math again because it's going to be exactly the same as what we did on the front side. The difference is instead of saying equal, it's an inequality, and so n is going to be any number greater than or equal to 14 1/3. In our second situation, it says that Diego has budgeted $35 from his summer job earnings to buy shorts and socks for soccer. He needs 5 pairs of socks and a pair of shorts. The socks cost different amounts, and the shorts he wants cost $19.95. Let X represent the number of the price for 1 pair of socks, and write an expression for the total cost of socks and shorts. So we know he's going to buy 5 pairs of socks that cost X amount of money. We don't know, and we know the shorts he wants cost $19.95. So he's going to buy 5 pairs of socks for sum of price plus 1 pair of shorts for that cost there. That's our expression. Now to solve an equation, again that means an equal sign, he wants to spend exactly $35 on socks and shorts. So we'll set our expression 5x plus 19.95, and we'll set that equal to 35. And we're going to solve for 35. So we'll subtract 19.95 from both sides, minus 19.95. And when I do this, I end up with 5x equals 35 minus 19.95 is $15.05. To get the x by itself, I divide both sides by 5. So the amount, the cost per sock is going to be $3.01. So what does that mean? To spend exactly $35 in socks, each pair of socks needs to be equal to $3.01. List some other possible prices for socks that would allow him to stay within his budget. So in this case here, if he's going to stay in his budget, he needs to spend, so we're going to say, for that to work, it would be any price under $3.01. If he spends $3.01 for 5 socks, we know it works. If he pays any price under that per sock, it's gonna work just fine. So he could do $2.50 for a pair of socks. He could do simply $3 for a pair of socks. Any other price would work as long as it's under $3.01. Write an inequality to represent the amount. Okay, so to do that, what we do is we change what we had before. Remember, before we said that x had to equal $3.01. If we solve this with an inequality, starting from the beginning, right, we started with 5x plus 19.95, we would say that needs to be less than or equal to 35. We're not going to say greater because he can't go over that. He's going to have to keep the price under $35. So now when we work this out in the solution, we find out that x is going to be less than or equal to less than or equal to $3.01. So the same steps are here, but the difference is now I have an inequality instead of solution, meaning the pair of socks need to be all less than or equal to $3.01 each to work out. Next one, granola bars and savings. It says Kieran has saved $100 in a bank account. The account doesn't earn interest. He asked Claire to help him figure out how much he could take out each month, if he needs to have at least $25 in the account a year from now. Claire wrote the inequality negative 12x plus 100 is greater than or equal to 25. Where x represents the amount Kieran takes out each month, what does negative 12x represent? So in our situation here, you have a couple things. You have the negative 12x, you have the plus 100, and you have the greater than or equal to 25. And we can find all these pieces in our story up here. The $100 represents what he's already saved. That's the $100. Because he needs to have at least $25, whatever happens here needs to be at least, it can be more, but it needs to be at least $25. That's why we do greater than or equal to 25. This negative 12x, what it's talking about here, is the amount he would take out each month. Because he's taking it out, it's going to be negative, and 12 are the number of months in a year, and x represents the amount that he would do. So find some values of x that would work for Kieran, or Kiran. So let's find some values here. We could do, if I'm looking at negative 12x plus 100 being greater than or equal to 25, I need to think about some numbers that could work there. And again, just using some reason here, some logic. Let's say that x was equal to 5. If x was equal to 5, I'd end up with negative 12 times 5, which becomes a negative 60 plus 100, and that becomes a positive 40. Is positive 40 greater than or equal to 25? Yes, it is. That would work. How about if he took out 3, right? $3 a month. Well, 3 times negative 12 is a negative 36 plus 100, right? That's going to get you 64. That's greater than 25, no problem. So we know it could be anywhere from 3 to 4 to 5. Let's try a 6 real quick. If he took out $6 every month, 6 times negative 12 is negative 72. Now negative 72 plus 100, that's going to get you 28. Is 28 greater than or equal to 25? It sure is. So I know some values that would work. It'd be $6 a month, $5 a month, $3 a month. Let's keep going and see what happens. What if we tried 7? If you did 7, you'd end up with negative 12 times 7, which ends up being 84. right? That's negative 84. Negative 84 plus 100 is going to be equal to 16, right? Is 16 greater than or equal to 25? Nope, it doesn't work. That's not going to work out. So we know that 7 is not going to be a solution to that inequality. So whatever we do here, whatever x value you want to use, we know that it has to be somewhere less than 6. If it gets to 7, it's not going to work. And we can find the exact number in a second, but that's just kind of looking at it, just using some numbers and doing some estimation there, right? And doing some work. So we could express all the values that would work using either x is less than a number or x is greater than a number. Which one should we use? Based upon our work so far, we should say x should be something less than a value of a number. Less than. X should be less than. Because we know it's going to be something like, if we have a number line, okay, and here's where 6 is, and here's where 7 is, and 5. We know that 6 works, and 5 works. It's going to be any number going that direction. So it's less than 6 or something in that range. We're not going to say it's greater than, because that's going to use numbers here which are not going to work for us. We can't use those. Let's write an answer to Kieran's question then using mathematical notation. So here's what it looks like. If I take the inequality negative 12x plus 100 and I say it's greater than or equal to 25, and then we solve this out. Normally we would do negative 100, subtract 100 from both sides. We have negative 12x, and then we have greater than or equal to, in this case here, negative 75. Now, when I divide both sides by negative 12, I end up with, that goes away, x on this side, and 75 divided by 12 is 6.25, okay? Now, we just said a second ago that x has to be less than or equal to in our solution. So using that logic, I can plug that right up in here to this space right there. Notice that this inequality sign has now gone the other direction. And the reason for that, we'll talk about another time, but just using our rationale from before, we know that x has to be a value that is less than, we knew 6, now we know it's 6.25, or less than or equal to 6.25. If we kept this as greater than, it just isn't going to work out, is it? If it was greater than 6, then the number 7 would work, and we've already proven that it doesn't work. So the sign here, the inequality, has to be reversed there. All right? So that's just using some logic, we can see that we have to reverse the sign. And you can probably have a conversation in your class about what do you see happening here that would cause that to take place. What step did we do right here that would initiate the flip of the sign right there? And that's something for you to take a look at and think about, and then we'll do some more problems and see if we can come up with a reason for that in a bit. Okay, let's take a look at the next page. It says that a teacher wants to buy 9 boxes of granola bars for a school trip. Each box usually costs $7, but many grocery stores are having a sale on granola bars this week. Different stores are selling boxes of granola bars at different discounts. So we have some discounts going on. If X represents the dollar amount of the discount, then the amount the teacher will pay can be expressed as 9 times 7 minus X. So this becomes, well, in this expression, what does the quantity 7 minus X represent? So 7 minus X is the cost, right, for a box of granola less the discount, or minus the discount, right? It's the box of granola minus the discount is what 7 minus X stands for. Now that 9 means we have 9 boxes. That's where the 9 comes from there. The teacher has $36 to spend on granola bars. So now the equation 9 times 7 minus X equals 36 works, and that represents a situation where they spend all $36. Solve this equation. Sure. So do 9 times 7 minus X equals 36. I can again divide by 9 or distribute. Because I know that 9 goes into 36 evenly, I'm going to divide first of all. So 7 minus x is going to equal 4. Now again, using some reason here and just some logic, 7 minus what number can get you to 4? Well, just logically we know this is going to be 3. 7 minus 3 equals 4. Now let's work this out this way and just show what this means. 7 minus x equals 4. If I subtract 7 from both sides, I end up with a negative x equals a negative 3, right? A little funky there. But if I was to multiply both sides by a negative 1 times a negative x equals a positive x, and negative 3 times a negative 1 equals a positive 3. So just using logic, I know it's going to be a positive 3, right? Or I can do the work here and multiply negative 1 to change the sign of the variable. So what does a solution mean? Okay, what it means is if the discount is $3, then the teacher will spend exactly $36. So if the discount is $3, they're going to spend exactly $36. Now in part D it says the teacher does not have to spend all of it. Write an inequality relating 36 in that situation. So here we would do 9 times 7 minus x, and we want to know that we want to say whatever that's going to be, they don't have to spend it all. It can't be more than 36. It needs to be less than or equal to 36. Can't be greater, right? That's how much they have, 36, but it can definitely be less than that. So now when we solve this out, we divide both sides by 9 again, and you have 7 minus x is less than or equal to 4. And so the same thing ends up being true here, right? That's our inequality. And we've already said that in this case here, we know that this 7 minus what is less than or equal to 4? We know that x has to be a 3 right there, right? We know it has to be a 3. So x is going to be a 3. The question though is x going to be greater than or equal to 3, or is x going to be less than or equal to 3? That becomes the question we have to figure out as we look for a solution there. Let's look at the next question, because that's really what it's asking you to do. Right? So it says the solution must look like one of these two things. So when we look at 7 minus x, and then we have to decide what goes in here compared to the 4, less than or greater than 3, less than 3 or greater than 3, we need to think about, well, let's use some logic. All right, if it's 3, 7 minus 3 is 4, and so 4 equals 4. That works no problem. If I plugged 4 in there, 7 minus 4 is going to be 3, and 3 is going to be, well, in our case here, we already had less than or equal to, right? That's what we said before, was less than or equal, if we don't move anything, less than or equal to 3, that works there. If it's 2, 7 minus 2 is 5, and that's not going to work out too well. So for our solution here, we're going to say that x needs to be, x needs to be, we can keep this like it is, but x is going to have to be something bigger than 3, right? Bigger there. So when I solve this, I do 7 minus x is less than or equal to 4. I subtract 7 from both sides, and you have negative x is less than or equal to negative 3. As you're looking at that, you go, well, that's just weird. I don't know how that's going to work. But when I plug some numbers in for x, again, this is negative times something less than or equal to negative 3, whatever it's going to be. I know I'm going to put a number in here that's going to work. So if I put a 3 in that spot, then 3 is equal to negative 3. If I put a 4 in there, negative 4 is less than negative 3. That would work there. So my x value actually needs to be, x has to end up being greater than or equal to 3, because we can see 3 works and 4 works. So you have to use a little bit of reasoning or logic there to make that work out. And again, what's taken place is that this inequality, as we go down, ends up going the opposite direction there, or being kind of, we call flipping the sign a little bit. Not the quite the language we want to use in today's lesson, but since this is a review, it probably came up in one of your conversations. Okay, so let's take a look at your homework for the day. All right, the solution to 5 minus 3x is greater than 35 is either x is greater than negative 10 or negative 10 is greater than x. Which solution is correct, and explain how you know. So, using some logic here, if we were to make a number line like so, all right, and let's just kind of put some numbers in here. If I use the number negative 10 and I plugged it in here, if I put negative 10 in this spot, all right, let's do a little bit of some work here. Okay, I have 5 minus 3x is greater than 35. If I subtract 5 from both sides, I have negative 3x is greater than 30. So if I put a negative 10 in this space, I'd have negative 3 times a negative 10, which is a positive 30. Is that greater than 30? Not quite. It doesn't quite work out. It's not going to be quite what I need it to be, is it? Okay, because it's not equal. It's not going to quite work out. What if I put a 0 in there? Is negative 3 times 0 greater than 30? In our case here, we would say negative 3 or 0 is not greater than 30. That's not going to work. So if I have 0 here, that doesn't work at all. Negative 10's not working out too well for me, is it? Okay, so that's not quite working out here. Let's pick one in the middle real quick. Let's do a negative 5. Just try it out. What happens if I do negative 3 times a negative 5? Is that greater than 30? 3 times 5 is going to be a positive 15. Is that greater than 30? Nope, that's not going to work out too well. So let's go this way. Let's do negative 100. So negative 3 times a negative 100, is that greater than 30? Negative 3 times a negative 100 is a positive 300. That definitely is greater than 30. So that's going to work there. So in terms of my values of x, the question is x going to be greater than negative 10? Is x going to be this way? Or is x going to be less than negative 10? And taking a look at our chart here, when I go greater than negative 10, it doesn't work. When I go less than, not equal to, but less than, it does work. So we would say that x is going to be less than negative 10. This one they just wrote the opposite way. If I wrote it the other way, it would look like this. X less than, see it still points to the x, negative 10. It's the same thing, just written in a little different order, okay? So that would be my correct solution there. Number 2, the school band director determined from past experience that they charge $T for a ticket to a concert. They can expect attendance of 1,000 minus 50 T. So that's my ticket price, right? They use that model to figure out the ticket price needs to be $8 or greater in order for at least 600 to attend. Do you agree? Well, let's see what happens. If I had 1,000 people and I did 50 times T, which they said T was $8, what do I get? I get 1,000 minus 400, which gets you $600 or 600 people. That works so far, right? So let's see, $8 or greater is the question. Let's try another one. Let's do 1,000 minus 50 times 9. That becomes 1,000 minus 450, and 1,000 minus 450 is 550. Now wait a second, that is less than that, isn't it? So $8 or greater, if it was 9, then I'm not getting my 600 people, am I? Okay, let's try 7 real quick. So 1,000 minus 50 times 7, oops, 7, that'll be 1,000 minus 350, which will give me 650. Does that work out for what I'm looking for? It sure does. So the reality is we would say we disagree, so we're going to disagree, and it should be $8 or less in order to get your 600 people, according to just putting some numbers in there. is what it should be, $8 or less. All right, number 3, which inequality is true when the value of x is -3? So looking here, we have a minus, -3, -6. So minus and minus becomes a plus. So that's a +3, +3 and a -6, which becomes a simple -3. Is -3 less than -3.5? We would say no. Here's the same thing there. So is a -3 less than 3. Oh, sorry, it's not less than there. Is -3 greater than 3.5? We would say no. Same thing here. Is -3 greater than -3.5? We would say yes. And this one here, a little different now, still using -3. -3 minus 6 is actually going to be a -9. Is -9 greater than -3.5? We would say no. So our solution is going to be this one right there. Number 4, draw the solution set for each one. Okay, for each inequality. Remember, when it has the less than or equal to sign, that's going to be a closed circle. When it has just the plain old less than or equal sign, that will be an open circle. So we want a value of x less than or equal to 5. So I go to 5, less than or equal means I close that circle up, and it's less than 5, so we draw an arrow going this way, and technically you would go all the way to the end of your line and draw an arrow going like that. Okay, just a nice long line like so. The next one, we have x is less than 5/2. I'll rewrite it again real quick. X is less than 5/2. 5/2 is the same as what? 2.5. So here's 2.5, and it's an open circle because it's just less than. And then we draw our arrow this way, like so. Okay, and that's what we have there. Number 5, write 3 different equations that match the tape diagram. So what could we say? We could say this is 19 plus 1, 2, 3, 4, 5, 6, 7x equals 40. We could change the order and say 7x plus 19 equals 40. We could start moving things around and say 40 minus 19, so 40 minus the 19 is going to equal what's left with the 7x. That works there. Or we could do 40 minus the 7x equals the 19. Right? Just moving some stuff around. Any of those are fine, and you might think of some other ones as well. Number 6. A baker wants to reduce the amount of sugar in his cake recipes. He decides to reduce the amount he used in one cake by ½ a cup. He then uses 4½ cups of sugar to bake 6 cakes. Describe how a tape diagram represents a story. Okay, so the 4½ here represents the number of cups of sugar he uses in 6 cakes. 1, 2, 3, 4, 5, 6. All right. So that's what that represents there. The 4½ represents the number of total amount of sugar for all the cakes. Each box represents the cake in itself, doesn't it? Okay, so each box with the x minus 1/2, that represents one cake. The x in itself represents the original amount of sugar. Okay. And of course the minus 1/2 is ½ a cup less per cake. All right, and that's what we have so far. So how much sugar was in the cake recipe originally? Well, what we'll do is we'll say that we have x minus 1/2, and we have 6 of those. 1, 2, 3, 4, 6 is equal to 4½ So to solve that out, I can distribute if we choose to. We'd have 6x. 6 times -1/2 is -3, and that equals 4½ 4 1/2. I can add 3 to this side, add 3 to that side, so 6x equals 7½ 7½ is the same as 15/2. And if I multiply by the reciprocal, 1/6, right, that goes away, and so x is going to be equal to 15/12, which can reduce. 3 goes in there 5 times, 3 goes in there 4 times, and that becomes 1 1/4. So originally there was 1 1/4 cups of sugar inside of each cake. And that's what we get for number 6. And one final one for the day, number 7. Couple steps here on this one, so hang in there with me. It says 1 year ago, Claire was 4 feet 6 inches tall. Now she's 4 feet 10 inches tall. By what percentage did the height increase? All right. First thing I did here is I looked and said, well, how many inches tall was she to start with? Okay, so I took the 4 feet and I multiplied that by 12 because there's 12 inches in a foot. So we knew that she was 48 plus 6. She was 54 inches tall to start with last year. Now she's 4 feet 10 inches. So we went from 6 to 10. So it increased by 4. So she had 54 inches and she went up by 4 more inches. So it was an increase of 4 inches out of the 54 that she had to start with. 4 divided by 54 is equal to 0.07, and it goes on. You can say 0.74. As a percentage here, move over 2 spaces, that's going to be about 7%. So her percentage increase from her original height is going to be 7%. And again, that's found by how much does she grow or decrease by? She grew by 4 inches from the original amount. So the change divided by the original tells you her percentage of change. That's it for today, and we'll see you next time.